billion years ago, two massive, whirling black holes collided, sending a gravitational ripple through the space-time fabric of the universe. Like a tsunami moving through the ocean, that wave passed through space until it washed past Earth last September. 100 years ago, Albert Einstein predicted exactly this type of event, that massive objects moving in certain ways will cause space-time ripples, or gravitational waves. But the technology didn't exist back then to try and catch one of those waves, and after a few years, even Einstein himself began questioning the theory. It must have been incredibly bewildering and frustrating to theorize on such a grand scale, but constantly run into the limitations of man's ability to verify the interstellar events that your core scientific ideas are based on. Time passed, and in 1979, after a series of advances in gravitational astrophysics, the National Science Foundation greenlit Caltech and MIT to develop a design for a gigantic instrument capable of detecting Einstein's gravitational waves. 15 years later, construction began on the $250 million Laser Interferometer Gravitational Wave Observatory, or LIGO, which is a pair of L-shaped devices with arms 4 kilometers long, one in Washington state and the other in Louisiana. They are essentially laser rulers, so precise they can detect differences as small as 1/1000th of a proton's width. Theoretically, that sensitivity allows them to see a gravitational wave as it moves by, and stretches the arms just enough to cause the laser light to warble. But for the first 8 years LIGO gathered data, it did not detect any waves, so an additional $205 million was spent upgrading the system. On the morning of September 14th, 2015, when the advanced LIGO had just come back online after 5 years of refurbishments, lo and behold, it caught a wave. Both LIGO detection locations recorded the same exact changes in frequency.
I knew that there was something going on because I subscribed